everyone, to today's Synergist webinar, The Role of Site Noise Surveys and OSHA Compliance. I'm Kay Bechtold, Managing Editor of the Synergist, the magazine of AIHA. I'd like to thank everyone for joining us today, and especially Larson Davis for sponsoring this webinar. Today's speaker is Ken Cox, Product Manager for Larson Davis, a division of PCB Piezotronics. With 35 years of experience in the sound and vibration industry, Ken has a strong background in both technical product design and the human factors involved in developing products for workplace noise safety. Ken represents the U.S. as an individual expert in IEC TC29 working groups for the development of standards for sound level meters and acoustic calibrators, and serves as an individual expert for ANSI S1 and S12 standards committees. And now I'll turn the presentation over to Ken.
All right. Hello, everyone. Thank you for spending your time to come join us here in this presentation. And also thank you to AIHA for hosting the presentation and Kay for the nice introduction. Appreciate that. The goal of this presentation here, as you can see, is to talk about site noise surveys and the role that they have in our desire to be OSHA compliant. But even more than OSHA compliance, we really want to protect our workers and their hearing. And so we'll talk about that a little bit today. And I have in here just a couple of slides on myself as an introduction. Kay already did a great job of that, so I'm going to move through those really quickly. As she mentioned, I'm a product manager at Larson Davis. We're a division of PCB Piezotronics, and this is a little bit about Larson Davis as a company. And we're a U.S. company based in Utah. So let's jump into the core of what you really all joined and wanted to hear today. So, as we're all interested in protecting workers from exposure to noise and preserving hearing, I wanted, or my goal in today's meeting was to set the groundwork a little bit, and we'll explain what NIHL is for some people. Some people this may be a common term, for others it may not. It stands for noise-induced hearing loss. We'll also talk a little bit about the OSHA requirements around that, so that not only can we make sure that we're protecting workers' hearing, but we're also compliant with laws and regulations that exist in the U.S. That I have a few slides on that as an introduction if we have some attendees who are new and can kind of get the background there. But really the meat of what I want to talk about today is how we determine if there's a risk on my work site of noise exposure, how I can use a site survey to help me determine that, and then if there is a risk, what are some of my next steps to make sure that I'm compliant and keeping my workers safe. So with that said, let's kind of jump into some of the content here. So if we talk to hearing professionals, they'll tell you there are two primary reasons why people lose their hearing. And one of those is what we know as age-related hearing loss, or presbycusis, if you want a big strange word there. And we all experience that. In fact, kind of a funny story. So I'm kind of the nerdy dad, and go home and having dinner one time with my children and explaining a little bit to this around the dinner table. And one of my daughters popped in and says, "Oh, Dad, we already know this stuff." And I'm like, "You know this stuff? How do you know this stuff?" And she says, "Well, when we go to school, we all know that we set a high frequency ringtone on our cell phones, and all the students can hear it and the teachers can't." And that that really is a true effect of the age-related hearing loss. As we get older, we lose hearing overall, but especially we lose the ability to hear high frequencies. That's not the one that we're primarily concerned about in protecting workers, or even in this presentation. What we're really interested in is what's known as the noise-induced hearing loss. And the reason we're interested in that is it's preventable. And a few things we should know about the noise-induced hearing loss also is it has a cumulative effect. That meaning that exposure to loud noises over a period of time can build up and create hearing loss, but it can also be very immediate. You know, exposure to very high levels can cause immediate damage. So there's both an immediate and a long-term exposure effect. So if we think, oh, I can be exposed to loud noises, you know, once a week or occasionally, that builds up over time and can lead to long-term noise-induced hearing loss. So that's a brief description there. Now let's switch gear a little bit and just talk about the regulation side of that. So OSHA for a long time has regulated noise at work, and they have requirements in place for that. I've listed on the slide here for those of you who like the technical details. You can see where you can find the noise regulation. But the key thing here that I really wanted to share with you are just the limits. So OSHA has specified a PEL of 90 dBA over an 8-hour work shift. And a lot of times in the US we measure that as a dose, and if a person has an equivalent noise of 90 dBA for 8 hours, that's equivalent to 100% dose. There's an action level of 85 dBA or 50% dose. So a quick explanation of those, many of you are familiar with the PEL or personal exposure limit. That's the limit that people can't exceed. If in noise that levels exceed, something has to be done. And we'll talk later a little bit about what that can be done, what some of those options will be. The action level is if workers are exposed to levels above the action level, there are some things that employers need to provide that workers can use at their own discretion. And there's also some notifications that need to occur. So that's just a brief description of the requirements from OSHA. So a little bit of discussion about dose, because what we do in the US is a little bit different than the rest of the world. We use what's known as a 5 dB exchange rate. Exchange rate means I can exchange exposure noise level for exposure duration or time. And this little chart here, you can kind of see that if my limit, and it is 90 dB for 8 hours or 480 minutes, that's my limit for a PEL. I could exchange that and go 5 dB lower or higher here in this chart, 5 dB higher at 95, but half the exposure time or 240 minutes, 10 dB higher, a fourth. You can see that. So the dose or the TWA allows for that exchange of exposure time for level on that 5 dB rule. And this is kind of a little chart so you can see how that works. That's important to know because one of the controls that can be used for limiting noise exposure is what we call an administrative control, or just limiting the amount of time people are exposed to high levels of noise. But enough of that preparatory stuff here. Let's move on to risk assessment, which is probably why many of you are attending here. You want to know, do I need to do something on my job site? Are people at risk? So the first step I would recommend is just to look at the common things that are happening around the workplace. So I've listed a couple of them here that are you'll see them, you'll think, okay, those are pretty obvious. But if people are raising their voice to talk, that's a sign that it's pretty loud, and maybe you need to do something. A really good one here is if at the end of work people talk louder. There's a phenomena called temporary threshold shift, and probably all the people on here, you've experienced that, especially if you go to a loud ball game or a concert or something like that. You come out and you notice that you're talking louder. That's actually the ear's built-in protection mechanism. It shifts your threshold of hearing to protect your ear. that is also an indication, a really good strong indication that you've been exposed to noise levels that are too high. If you're experiencing that at work, it's a good indication there's something needs to be done. Obviously, there's workers complain about noise levels. And another one, if similar industries have a problem with excessive noise levels, it's probably a good indication you do also. So the last thing on my bullet here is if in this just simple risk assessment you think maybe I qualify for some of these, or some of these could be an issue, what's a recommended next step? And for me, the recommended next step is what we call a walkthrough or a site survey. And we'll go into a little detail now on what that is and what that involves and how to do that. And here's kind of the basic 4 steps we want to go through. And we'll have some slides on each one of these so that you'll have a little more information. But we want to gather some information up front to help us guide our measurement. We'll want to know, how, what, where we want to measure before we actually go make a measurement, so that we make sure that the data we gather is representative of the actual noise exposure. We'll talk about, how you can note that level on a map or something, and then what to do with that data once we have it. So let's jump into that here now. So as we're gathering our information, we need to keep in mind our goal of a site survey is we want to gather the information to help avoid or reduce the noise exposure of the people at the work site or that we're trying to protect. So if we realize that that's our goal, then it'll become obvious to us. One of the first things that we want to do is we want to determine what the loud noises are on the workplace, because that's what's going to really dominate the noise exposure. If somebody's working in an office that's relatively quiet, they can work there for a long time and it's not going to make a difference. It's where they go where it's loud. So one of the things we want to keep in mind is, how can I determine what those loud noise sources are? And it's not always easy. And there's 3 methods here that I've listed and we'll talk about in a bit that we can go through to help figure out what that is. And before I jump into this slide, I just wanted to say part of
Hi, Ken. If you can hear me, we have lost your audio. Thank you, everyone, for sending that chat.
Can you hear me now?
We can hear you now. Thank you so much.
Okay, sorry about that. Where did you lose my audio?
It's just been about 10 seconds.
Okay, sorry about that. I was leaning over on my desk and I think I accidentally pushed the mute on my headset. So thanks for catching me there.
Totally understand.
So just backing up a little bit, I was talking about why it's important to gather this information. And the reason is because the noise levels at a typical work site many times are quite variable. Machines can turn on and off, fans can be on and off, doors can open and close to other things, workers can work in different areas. So it's important that we understand some of that, so that when we make our site survey, we get a good survey that's representative. If we go around and measure everything on a quiet day, we could inadvertently believe we don't have a noise problem when we actually do, and none of us want that, right? So a first step here that's recommended and is commonly done is just to have interviews with workers. Talk to the people at the work site. Ask them, you know, what are some of the things you do that are noisy, or where are some of the places you work that are noisy? Where are some of the places you don't like to be because it's noisy, right? Some simple questions we can ask. The people working there know where it's bad and the things they do that are loud. they can tell you that. So as I've listed here, some pros of that, it's pretty simple and it can provide a lot of insight. Some cons or some reasons why this isn't always ideal is it can be very subjective. There may be a person who's very noise sensitive for whom everything's noisy, or some people who don't want to stir the pot, so to speak, and they won't tell you anything. And so you can get that. You can also get incomplete information because people tend to provide you information on their most recent experiences. It can also be time consuming, especially to do the interviews, and having workers available is not always easy. It might be that they all have to, if they're in a mine or something, they all have to go to work at the same time, and it's not easy to pull them off to have an interview. So those are some of the challenges to doing interviews there that we have to be aware of. If we step to our next method here is, well, I shouldn't say this is part of considering when we talk to them, is we should consider, seasonal changes. Sometimes certain sites are noisier in the winter because you've got heating or fans, or in the summer, maybe it's not air conditioning. There's large noisy fans going, doors open, closed to make access to other noisy machinery. Consider, are the noisy machines operating? Also, have there been physical changes to the work site? There can be, it might be that a noise site was quiet, then new machinery was added. Now the work site is no longer quiet, and it might be necessary to do another site survey to determine are we still good or not. We also want to consider the mobility of the workers. And, are they always working near these noisy sources? Are they moving around sometimes, sometimes not? And keep that in mind. And from our worker surveys, if there's uncommon or variable noise sources, we want to try to capture those in our site survey. An example I use sometimes is, people working in a steel fabrication factory. There's a lot of noisy things there, but, if somebody ever drops a steel plate, that's really noisy, right? Maybe not very common, but could be noisy enough to exceed a person's daily dose in one event. So we want to be aware of those types of things. And I think we've talked a little bit about this already, the mobility, and just keep it in mind where workers are and what they're doing. So we've had our worker survey, we've looked around, we've talked to people, we've asked about the noise sources. So our next step here that we really want to do is jump in and let's actually make a measurement for our site survey. So when we do this, we want to make sure that the data we're gathering is good, solid data, because we're going to make some important decisions based upon this data. So, I recommend get a sound level meter that's a good quality sound level meter. Make sure you calibrate both before and after your measurement, just like you would do if you were doing an actual noise dosimetry survey. And then what you're going to do is you're going to take that meter and you're going to go out and you're going to start measuring in the work environment. Typically, you want to measure at locations where workers normally work. And ideally, you'd measure within 2 feet of where a person's head would normally be. So maybe they're an operator of a machine, you know where they would be because there's a seat. You can, maybe there's a worker there already operating the machine. You can just kind of go in and put your microphone near where they would be, where their head is. You don't want to be obviously interfering with their work or create a safety hazard. But you can make a short measurement there and get the noise level at that location. And typically what we're measuring is a metric known as LAEQ, or it's an A-weighted equivalent level. Some people ask me sometimes what an equivalent level is. I'll give you a quick definition. It's a number that represents the same amount of acoustic energy as you would of a variable noise level as if you had that level constant over the same period of time. So it's a good way of quantifying what we measure. And we want to make sure as we're measuring these situations, if a machine's off when we're out, maybe we want to see, can we get it turned on or come back at another time when it's on, and do those kinds of things. One item also that I wanted to mention is microphone type. Those of you, if you're familiar with sound level meters or even not, and you go out and you want to look at maybe I want to purchase or rent one, you'll notice that one of the choices you're commonly faced with is what type of microphone do you want? And there's several types. Called a free field microphone is one. A free field microphone is a microphone designed to measure most accurately when you point the microphone at the noise source. There's another type called a random microphone or a diffuse microphone. These are microphones that are designed to measure most accurately when sound comes from random directions. So a good example of a diffuse environment would be you're inside of a steel building, and maybe you have a machine that's making noise, but that noise goes out and it echoes off the floor and the ceiling and the walls and the back wall and all over. So ultimately it sounds like that sound is coming from all directions. That would be a diffuse field. So the technically correct answer is that if you're in one of those reverberant where there's lots of echoes, a diffuse field or a random incident microphone. The diffuse and random incidents are names for the same type of microphone, just different names. That would be technically the most correct. In today's modern sound level meters, though, many of them have a setting you can use a random or diffuse microphone and just tell it what response you want measured, and it'll automatically correct for you. So if you're very technically correct, you can be aware of that. I'll tell you on the practical side of things, the difference between a free field and a diffuse or random microphone, most of the differences are in high frequencies above about 4 kilohertz. When using the A-weighted measurement, those higher frequencies are attenuated. So in a lot of practical instances, it really doesn't matter, but sometimes it can, and you should be aware of that. So I wanted to point that out for you. So we're going to go out and make this measurement here. And the result is we're going to, interesting, I'm seeing the picture's blocked here for some reason, not sure why on that, but you'll come up with what's called a noise map. And if you look over here on the left, you'll see a sample handmade noise map. And let me explain what you're seeing here. This S1 would represent a sound source 1, S2 is some other sound source that's most likely stationary, and these lines here would be walls. Now, what this sound survey is all these other little circles here are points where somebody went and made a measurement, and they just wrote down inside of there what the measurement level was. Now, if you notice on these, in this example, someone would try to determine where the noise level was constant. So at 94 dB here, here, and here, and we could theoretically connect those levels with a line and say, this line around here represents an area where we think the noise exposure is approximately 94 dB from this noise source here, because it's, most likely the dominant one there. Come out here, okay, here's some 90 dB, right? You can see this noise source, we get closer to it. We're measuring a little quieter here, but we got a 96 here, maybe because we're getting some combination from the two, right? But you can see I'm going to start to build this map of how loud it is in different locations in this room with these two noisy devices here. And from this example, you'll notice some interesting things come out right away, right? You can see, well, gee, if I'm up here in this location, I'm measuring 84 dB. So I'm actually just slightly below my action level, right? So if I'm there, I'm probably okay. But if I'm working over here, I'm 6 dB above my PEL level of 90 dB. And whoever's working here is definitely at risk, right? And so we start to build this understanding of how noisy it is and where it's noisier than other places, which is important to know. And this is a sample report from the DoD. It's now old and not used, but I put it in here kind of as an example of something somebody might use to report the locations, the different levels and things like that that they might use as a way to report these. Although very commonly, just a hand-drawn map like this is used. There is one company I'm aware of that produces software that you can put a map of your site into and make your measurements, and it'll build the contours for you. It's a bit expensive, though. I'll just say that about it. But there is a commercial solution out there for that if it's something that you're interested in. So now we've gone out. We've made our initial assessment. We've assumed maybe I have a risk, so I'm going to take a meter, walk around, make my noise survey. I got my data. I've got my map. What do I do with it next? Is our logical question, right? So there aren't any, well, there are some firm rules, I should say. Firm rule number one is if you have workers working an 8-hour shift at a location where the noise level is greater than 90 dB, they are in a location where they're exceeding the OSHA allowed noise dose, and mitigation is required in those instances. And so that one's a firm one there. Also, if during your site survey you find you have workers working an 8-hour shift at a location where the level is regularly above 85 dB but less than 90 dB, then we fall between the PEL and the action limit, and there we have some requirements also that we have to put up signage noting that that there's a noise hazard in the area and make hearing protection available, or alternately do something to make the noise levels lower in that location. But then we have the situation from our noise surveys where, we haven't measured for 8 hours, because typically in a noise survey you'll make a measurement for maybe 30 seconds at each location to get an idea. So you don't know what it is really 8 hours. And so then we're asking ourselves, what do I do? So here is my recommendation. If you're measuring at any location greater than 85 dBA, that's a clear indication that there's probably some action that needs to occur, and that you should take a formal noise dose measurement at that location to figure out what the actual exposure is for workers there. I'd also recommend, if you see average noise levels above 80 dBA, I would also do a formal noise measurement, just because we don't know for certain when we're doing our site survey if we've captured all the noise, and maybe there's noise levels that occur during the shift, people move, things turn on and off, and maybe, as part of our risk management strategy, we're saying, I want to make sure that I'm keeping my workers safe, so I'm going to do a more formal survey just to make sure that my data says they're okay, and if it says it's not, that I know I have the information to take the appropriate steps to keep them safe. So those are my recommendations there. And in making that process, or in making those determinations, we need to consider workers' time at each location. If you remember way back at the beginning, I had the slide on dose, and we talked a little bit about exchange rate. And with exchange rate, we had the ability to exchange noise level for time. So, you have to keep that in mind here. If I measure, 85 dBA at a location, but I know nobody's ever in that location for more than an hour, and it's less than 90, then I can go back to that exchange rate and say, okay, if it's quiet in other locations, I'm probably okay here. So you have to put in a little bit of common sense into it, right? And but if they're in the noisy environment 8 hours, then it's definitely a concern.
Hey, Ken, this is Kay. I had a question come in. Someone was asking, is the formal measurement an area or personal sample?
Good question. And if we can hold on that, I'm moving into that as my next part of my presentation here.
Okay, great. Thank you.
I'm actually starting this next slide. So whoever it was reading my mind, I guess. And I don't know, that might be a scary thought, but we'll go with it anyway. So if you determine I need to do a formal measurement, there are actually two methods that can be used for that. As was mentioned by Kay in the comment, there was one called a personal measurement. What that is that's we call it a noise dosimetry measurement normally. What we have is a product like this one here. It's worn by a worker for their whole work shift, and it just sits and measures the noise as they move around through their whatever job they're doing. And at the end of the 8 hours, the person making the measurement can take the dosimeter and it will report a single number for whatever that worker was exposed to. There's a standard for these, ANSI S1.25 in the US, and these devices are typically compliant with that. There's another method, I think the word used by Kay was a location. We sometimes call these task-based measurements also, because what is happening is you measure the noise at a location and you can determine the time a worker is at that location, and mathematically you can approximate their noise exposure. There's a standard for doing this. It's ISO 9612 that's listed here. And the devices used for this would normally be a sound level compliant with the ANSI S1.4 sound level meter standard. So a little more insight into these two methodologies. In the OSHA technical handbook, it says that you can use either method, but there's a little caveat there that says you can use the dosimetry method and that's acceptable. If you want to use the task-based or location-based, you have to prove that you get results as good as you'd get with the dosimetry. So, I would say you're a little safer using the dosimetry method, if you ever have to prove your data to OSHA. Not to say you can't use the ISO 9612 method. Commonly, I would say, a huge majority of North American people use the dosimetry method. This task-based method is commonly used in Europe. So there's a case that could be made for either method. If it were me making the decision and I'm based here in North America, I would use a noise dosimeter simply because that's the accepted practice. And if you have a good calibrated noise dosimeter and you can show that you have a good program, your measurement's valid, then you have a good standing with OSHA if they ever come audit you or want to know what you're doing. So those are the two choices though. And frankly, most products you buy today, you could do either one with a sound level meter, and you could potentially do either one with the noise dosimeter. The problem with using a noise dosimeter for the task base is it isn't compliant with the right standards in a lot of instances. So let's move on now, and let's say that we've determined we want to make an actual measurement and determine what the actual exposure of my workers is. So for for sake of discussion here, I'm going to focus on the noise dosimeter method just because that's by far the most common method used here in North America, but don't want to imply that other methods aren't good or valuable. So in the job-based or worker-based measurement, what happens is you have a worker, they wear a noise dosimeter for a complete shift. So here's an example of an individual. The noise dosimeter is mounted on the shoulder near the ear. Here's the microphone, and they just wear it around for their whole shift. And we talked a little bit earlier about the task-based measurement. So that all sounds good and easy. Until we ask ourselves one simple question. Do our workers really want to wear a noise dosimeter around on their shoulder for an entire shift? And the answer is some of them aren't really happy about that, right? And when they're not happy about it, you have to worry about, am I going to get a good measurement, or are they going to tamper with their measurement or do something else, right? So I wanted to talk briefly about some of the things that we can do if we're making a noise dosimeter measurement to make sure that we get a good measurement. And I'll step in here. One thing that some companies do is they just simply have the person making the measurement sits and observes the workers for the whole time. Okay, I've listed here some of the pros and cons, or pluses or minuses. That one plus is it's very objective, right? You can see what's going on. You can observe the workers all the time, and if they're doing something they shouldn't do, you'll see it. Another thing that I didn't list on the slide here also that's good, because sometimes people are making the measurements where they know it's too noisy, and really what you're doing is you're measuring the noise level to verify that the controls you have in place are adequate. And a common control that we're all familiar with are hearing protectors, either the over the ear or the foamy earplugs. Well, one of the challenges people have with the hearing protection is people don't wear them properly. They take off the earmuffs, or they don't put the foamies in all the way. So if you're observing the measurement, you can tell if the hearing protection is being worn properly. So that's another pro I didn't list here. The cons, or the negatives, are pretty obvious, right? It's time consuming. You're going to spend 8 hours there watching a worker work to make sure it's right. And the other one is it may not be easy to be present. The worker may be working in a restricted area where it's hard to gain access. So a few things to consider with observing the measurement. So let's move on to technique number 2 that's readily available in commercial products today, and that is just to record audio. And we might ask ourselves, gee, why do I want to record the audio? Well, there's a number of reasons recording audio can be valuable. Number one, if there's a loud noise that happens, and I should say the devices that record audio do not record the complete work shift. They only record when it's loud. And that's key to note, because one of the things that workers are concerned about is they're being recorded the whole time they work. And that's something you kind of have to decide how you want to deal with. In reality, they only record when it's loud. But, if you have a worker who says, hey, I want to see what happens if I yell into this thing, you'll have an audio recording with some person yelling in the microphone, and you'll know that's why it was loud. So it's beneficial there. But sometimes also, there'll be certain very loud noises that you'll want to know what they are, and the audio recording gives you some tools so that you can listen to that noise and hopefully identify the source of it. It's also, excuse me, it's also very objective. The recording doesn't lie. Yesterday I've been talking a lot in some meetings we have here, and I'm not used to talking loud all the time, so it's made my voice a little bit hoarse here, so I apologize for that. So, and we talked about some of the negatives, right? Sometimes you'll hear a recording of a sound and multiple sources will sound similar, and it's hard to identify what that is. And then the privacy concerns are the obvious other thing that you have there. But the good thing about the recording audio is for the person making the measurement, it's your choice. It's not like you have to do it or you don't have to do it. It's one of the tools available to you to determine if there's compliance if you don't want to sit there all the time and watch. Another tool that's available on a lot of products today that I think is a really neat thing is the ability to measure motion. So a lot of products now have an accelerometer built into them, just like your cell phone does, and it can measure when the device is in motion and report that. So you might, and this is just a little chart here I put at the bottom so you can kind of see that. The green lines here at the bottom represent when the noise dosimeter was not moving. And so if this were a measurement I was looking at, I'd look at, hey, I've got this about 1 hour period here. Okay, maybe this was the time when the worker was at lunch. They took the noise dosimeter off, set it on the table. I'm not worried, right? But if you got a 2 hour block in the middle here, you might ask the worker, hey, what happened here? How come this thing didn't move at all? Because they may have taken it off if they weren't being watched, right? And then you're not getting a good representative measurement of what they're actually experiencing. So that I think is a really good, neat tool that's available for people, again, to make sure that that measurement you're getting is good because the worker's complying with the measurement to help you get good data and make sure it's good. And another item on here that I didn't put a slide on, but but as I'm talking here, I think I ought to mention is just explain to people when you make a measurement why you're doing it. You're asking them to wear that noise dosimeter for a work shift so that you can ensure you're protecting their hearing, and their cooperation helps you to make sure that they remain safe. It's not like we're trying to make people do something they don't want to do just for no reason at all, right? It's really for their benefit that they make it good and participate. So that's another thing to consider there. So you get that measurement, and I didn't put any slides in here to talk about what we do. If you get measurements, I talked a little bit about what what OSHA requires. You could reach out. I think there's other things and other resources available, and we're very much willing to talk again if there's something you want to know. What happens if my noise level comes back high? I'll refer you to the OSHA technical manual. Here is a good source that you can go to. There are also many classes and other things you can go to. I did mention earlier I'd talk briefly about a few things that you can do, and so because I mentioned that, I'll talk about them briefly here. I wanted to it's about close to time when I wanted to quit here and leave some time for Q&A. So I want to cut off here soon. But generally speaking, if you find that you have a problem, the things you can do are grouped into 3 major groups. So one, and this is the preferred method by OSHA, is called an engineering control. What an engineering control is you just do something to make the workspace quieter. Maybe it's you replace an old noisy machine with a newer, quieter machine. You do some maintenance. Maintenance sometimes will help a lot, balance unbalanced things. Even some places will put noisy machines in soundproof enclosures so that that sound doesn't propagate out where the workers are. A lot of things that can happen there under engineering controls. The benefit of engineering controls is workers don't have to wear hearing protection or do things like that to remain safe. You're almost guaranteeing safety because wherever they go, the noise levels are appropriate. The next one I talked about briefly was administrative controls, and that's just limiting workers' time in noisy environments so that overall their noise dose is below the allowed limit. The third one is actually the hearing protection that we talked about a little bit. And we see that in a lot of places, most commonly because it's relatively inexpensive when compared to some engineering controls. The challenge with hearing protection, I'll just tell you, is getting people to comply. Wear those earplugs or wear those earmuffs. People don't always like to wear an earmuff because they're hot, sweaty, and uncomfortable. Earplugs, you can't hear other people. Um, not all people like them. They're not comfortable. So compliance with wearing the hearing protection is a challenge, and getting rated protection is also a challenge. So with that said, I want to thank everybody for your participation and joining me. I've enjoyed doing this and appreciate it, and I'll now open up for questions.
Okay, thanks, Ken. It looks like we have about 13 or 14 minutes left for questions. Just a reminder, if you'd like to ask a question, please type it into the chat window on the right side of your screen and send it to everyone. Ken, the first question I have, looks like there was some discussion in the chat about, do you tell employees to turn their personal radios off? This person found that the sound level of the radio is also set above ambient levels.
That is an excellent question. So remember that as an employer, you are responsible for the workers' exposure to noise at the workplace. So even if it's a noise source that they control, it's still your responsibility. So if it were me, I would ask them to turn it down to a level that's that's not an issue. If compliance is an issue, I would probably consider, making it, telling them they couldn't use the radio. But ultimately, the employer's responsible for the workers' exposure while they're on the job site. And you're not responsible for things off the job site, but you are on the job site. So if that's something I would work to control that, yes.
Okay, great. Thank you. The next question I have is for an initial screening, what do you think of asking staff to use the NIOSH app for an initial screen? Any pros, cons, and pitfalls of potentially using this method?
Yeah, I mean, I have in other presentations let people know you have the NIOSH app and you can use it. The testing that NIOSH did was limited, and so if you use the NIOSH app, I would probably lower my thresholds. I would probably, maybe 75, or depending on things, maybe even as low as 70 before I say, hey, I need to do something better. But in the best of situation from NIOSH, they saw, like plus or minus 5 or 6 dB in measurements in a random environment at room temperature. And so it's possible, in real work environments, you can get more than that. And I would just keep that in mind.
Okay, thank you. The next question is, would you recommend putting signage at areas above 80 dBA or 85 dBA? This person says, I'm mainly conducting noise assessments at mechanical rooms, and the staff in those locations are typically only there for a short amount of time during their workday.
Yeah, so the NIOSH regulations say that you need to put signage if it's above 85. It doesn't mean you can't be more proactive and put a signage there if it's above 80 dBA. But if it's above 80 dBA and it's a constant noise level and it's not really a risk, I probably wouldn't put the signage up, because I wouldn't want to unduly alert people to something that's not really a risk. You have the risk then of conditioning them to ignore things when it is really a risk. So that would be my personal recommendation.
Okay, got it. The next question is, what about seasonal employees who may be exposed above the action level on a summer job? Are they to be included in a hearing conservation program?
So seasonal employees need to be included. The OSHA regulation is based upon an 8-hour workday. And so if an employee exceeds the 90 dBA PEL for an 8-hour shift period, then they need to be included into a noise or hearing conservation program.
Okay, thank you. Let's see. Our next question is, what do you recommend for measuring noise at gun ranges where impact noise exceeds 140 dB and range instructors are present for more than 8 hours?
So that is a good question. Probably what you need to do there, because most noise dosimeters don't measure above 140 dB or 143 dB peak. So that's a situation where I would use a sound level meter with a 1/4-inch microphone, because then you can measure up to 165 to 175 dBA, and then switch over to that location-based measurement. Or even some sound level meters will make a noise dose measurement, but that's what I would use there.
Okay, thank you. The next question was from a different person, I think more generally about the best time to use a sound level meter. So I'm not sure if there was anything else you wanted to add on that topic.
No, I mean, the best time to use a sound level meter is typically when you're doing that walk around survey and you just want to see what noises are, and you know because a lot of us, we hear 85 dB or 90 dB, but we don't really correlate that in our brains to something that's that loud and know what it is until we get some experience. So that sound level meter helps us get a number that's real. And what you really get, and we talked a little bit about the NIOSH app where you can use your cell phone, which is a very inexpensive way to do it, but it's less accurate. I would move to the sound level meter when you want a more accurate measurement.
Okay, thank you. The next question I have is, when would an octave band analysis be useful? And also, what would be the significance of finding a certain frequency range to be above 85 dB, but the overall sound level to be below 85 dB?
So a couple of questions there. I'll see if I can remember both of them and answer both. So the octave band analysis is typically used for selecting hearing protection. Some hearing protection devices attenuate different frequencies better than others. And if you find that there's a frequency component to the noise, it might be possible you can attenuate that frequency component, help people become compliant without attenuating the overall noise so much, so it can help speech intelligibility and things like that. So that's one use for that. The other part of the question, if I remember right, is what if I find a component is above 85 dB, but my overall level is not? And an example of that would be at a lower frequency. We do the A weighting, and A weighting attenuates low frequencies significantly. And so I could have 90 dB at 30 hertz or 50 hertz, and my A weighted level wouldn't be close to 90 dB, right? So in that situation, because we've used the A weighted, technically it's the A weighted that determines compliance for the OSHA requirements. There are always exceptions. The main exception that people have talked about for years are impulsive noises. Those are things like a clap, right? It's just instantly loud. The louder low frequencies don't tend to be an issue to my knowledge, because our ear doesn't hear them as well anyway. This might be a little too much information, but I'll try to tell you quickly. The A weighting is meant to approximate how our ears perceive noise, And we perceive those frequencies around 500 to 2000 hertz better than we perceive the low frequencies. And that's why a lot of times with older stereos, you turned up the volume to hear the bass because our ears just don't hear it as well. And that makes us less susceptible to damage at those low frequencies also.
Okay, great. Thank you. The next question I have is from another Ken. For dosimetry, what are the requirements during breaks or lunch periods? Should the dosimeter be removed or paused?
Yeah, normally the lunch and break period is not considered part of the noise dose unless, the lunch or break period is in a noisy area. But normally it isn't. There's a couple of things people do. Sometimes they pause it. Um, Sometimes they set up timers so the meter will only, measure maybe 8 to noon. There's a lunch break noon to 1. They'll turn off the meter then automatically, have it run 1 to 4 or 1 to 5, something like that. It's also possible with products to actually measure the whole shift and go in afterwards and just edit out those break times and recompute a noise dose also. So there's several options in there that you can do. I don't know that any one is better than the other. It's just personal preference.
Okay, great. Thank you. The next question I have is from Oscar, who asks, what are your recommendations regarding hearing protection devices based on the noise map, and what is the potential for overprotection?
So Oscar, I'll tell you right now, selection of hearing protection devices is a little bit out of my field here. So be aware of that. I know a little bit, and I shared that with you that you have some issues with the foamies or the in-ear protection devices. The main issue there is they're designed to be inserted fully, and people don't tend to do that. They'll put the tip in and then they don't get the rated protection. There's also, the issue of people don't put them in there at all. That's why, they're bright colors so that you can see easily if they're being worn or not. The over the ear, like the ear muffs, maybe people be familiar with like a shooting muff. Those tend to provide more consistent, reliable protection and will provide better protection, but and it's easy to verify compliance. You can see if somebody's wearing them or not, but people don't always like to wear them because they're awkward. They can get caught on stuff. They can get bumped and knocked off. If it's hot, they get sweaty. And so, that's some just general overall guidance, but in the specifics of what to pick, that's, there's some D ratings and things, but I think that's probably beyond what I'm prepared to discuss today. Sorry about that.
Yeah, no worries. I think we just have time for one more question. I know we've got a lot of questions. I just wanted to let everyone know that we'd be sending those along after the presentation as well. So let's end on the last question I have is, do you know of a method to assign an NRR to noise canceling technologies that are starting to show up in flight line PPE?
That I don't know. I know there's some standards for the NRRs, but I couldn't really address that specifically.
Okay, thank you. Unfortunately, that's all the time we have for today. Again, we'll be sharing all of the questions from today's event with Larson Davis. So if we didn't get to your question, please know that it will be passed along. I wanted to thank Ken Cox for his presentation, Larson Davis for sponsoring today's webinar, and all of our participants. Please visit aih.webvent.tv in the coming weeks for information about more new Synergist webinars in 2023. Thanks to everyone again, and have a great day.
Yeah, thank you everybody for your attendance.
This was great, and this actually concludes today's webcast. Thank you all for attending. The recording will be available at aiha.webvent.tv. We will send all registrants an email tomorrow with that link, and please visit our event calendar to sign up for future webcasts.